Hi, in this video, I'm going to introduce IPv4 variable length subnet masks. Okay, so you remember we had our barrel of apples, 100 apples. Well, how do we divide that barrel? 10 baskets of 10 apples each per basket, or 5 baskets of 20 apples per basket? Well, what if I need some baskets with 20 apples, but not all of them? I need some smaller baskets with just 10 apples per basket. Well, I could take one of those baskets of 20 apples and divide it further into 2 baskets of 10 apples each. Well, VLSM is the same thing. We just take a network, we subnet it, and then we can take one or more of those subnets and subnet it even further. Okay, so, and again, this is an exercise we go through because of IPv4, we're limited to the number of addresses that we have. Okay, so VLSM is nothing more than subnetting a subnet. Here I have the 10.0.0./8. So we'd already actually done VLSM. Okay, we took the /8, if you remember in previous videos, and we subnetted it into some /16 subnets by extending the 8 bits in the host, or borrowing 8 bits from the host, extending the network from a /18 to a /16. Then we subnetted further. We took one of those /16 subnets and we extended that mask another 8 bits and created a group of /24 subnets. Okay? That's all VLSM is. And by the way, in doing this, we still had these other /16 subnets, 10.0, 10.1, 10.2, 10.3, 10.5, all the way to 10.55, to 10.255 are still /16 subnets, each one with 65,534 usable hosts. But we only took this one 10.4.0.0 /16 subnet and subnet it further into some /24 subnets. Just taking one of the large baskets of apples and dividing that one basket further without touching the other baskets of apples. Okay, and I've mentioned that we go through this exercise because we're limited in our IPv4 address space. And the way we've subnet in IPv4 is we borrow from the subnet, from the host portion, to create these subnets. In IPv6, life is much easier. Okay, we actually have a portion of the network portion of the address, which is a portion for a subnet ID. We don't have to, although we can, we don't have to borrow from the host portion, the interface ID. Makes subnetting much easier. We don't have to worry about conserving IPv6 addresses. So in many cases, we don't even have to worry about VLSM. We just leave everything as a /64 subnet. Makes things much, much easier. Hey, we'll talk about subnetting in IPv6 in another video, and you'll see how simple it is. Okay, let's do an example. Okay, so the process of VLSM and IPv4 can be somewhat challenging, especially when we're not subnetting on a natural octet boundary. Okay, VLSM is used in IPv4. A lot of it's used just to conserve our precious, our limited IPv4 address space. We want to have the appropriate number of host addresses per subnet without unnecessary waste. We don't worry about this in IPv6, okay? We don't worry. We have plenty of addresses, okay? And so I won't go off too much more off on that tangent, but it's just another reason why we got to get to IPv6. Okay, typically done to conserve public IPv4 address space, but also sometimes necessary to even with our private IPv4 address space. Okay. Let's say we have this network 10.4.16.0/24. Okay, we've seen this network address /24 in other videos. All right, we're going to subnet this network into /27 networks because we have 4 buildings that, which are going to be each a separate subnet that needs at least, oh, I misspelled least there, but that's okay, with 28 hosts per subnet. This will give us 8 subnets with 30 usable hosts each. Let's take a look. So we took our /24 subnet. We're borrowing 3 bits from the host portion, from the /24 for the subnet. That leaves us with 5 host bits. This 5 host bits gives us 32 total addresses, 30 usable hosts per subnet. That's will accommodate, we need at least 28 per building. So this will do it. But this will give us 3 bit. This means we're going to subnet borrowing 3 bits from the host, which will give us 8 subnets. Okay. All right. So each building will get one of these subnets. Now, again, just remember, kind of a cool thing here. We have 32 total addresses per subnet, not subtracting the 2. Okay. Notice that our subnets increased by 32. Okay, so we're able to allocate, we're going to allocate each of the first 4 subnets to our buildings A, B, C, and D. Okay, so our buildings are going to get the first 4 subnets. Okay, so remember we have 8 subnets. Each subnet has a range of usable hosts. So the first host subnet is from 0 to .31. The next one, 32 to 63. And we can see that if we go down here, 32 is the subnet address, the usable host, 32 to 63. The next subnet is 64. Let's keep going. 64 to 95. Okay. And 96 to 127. So there's our 4 buildings. Okay. We still have 4 /27 subnets remaining. So each of our buildings is going to get one of the first 4. That leaves us with 4 /27 subnets. Okay. All right. We need to conserve our address space. This is, again, an exercise with IPv4, not with IPv6, okay? Because we have these we have these 3 point-to-point networks here between the buildings. These networks only require 2 addresses that have 2 usable hosts, 1 for each router, a network address and a broadcast address, 4 total host addresses, 2 usable. Okay. Now we could allocate 3 out of our 4 remaining /27s, 30 hosts each one for one of these point-to-point links. That leaves us with only 1 /27 subnet left. But with IPv4, we're trying to conserve. Why give somebody 20 apples when they only need, 10 apples or 2 apples? We don't want to give somebody a 20 apple basket that only needs 2 apples. Okay, so what if we take one of those baskets of apples and divide it into smaller baskets of apples? That's what we're going to do here. We're going to take that last /27, just that last one, and we're going to subnet it further. Let's take a look. Let's take that /27 subnet, and we're going to subnet it further. Okay. All right, so we only need 2 host bits. Why? 2 host bits gives us 4 total addresses. We only need -2 gives us 2 usable addresses. That's all we need for those point-to-point links. Okay, so let's subnet this /27 into a /30, 255, 255, 255, 252. We only need 2 host bits. Okay, so this is going to give us a total of 8 subnets, each one with 4 total hosts or 2 usable hosts. So what we've done here is taken one of our baskets and we've divided it into a bunch of smaller baskets with fewer apples. So what we've done here is we've taken our 1/27 subnet, subnetted it further into 8/30 subnets, each with 4 addresses. Can't use the network, can't use the broadcast, 2 usable hosts per subnet. Okay. All right, so 00, 01, 10, 11 are the bits. Okay. So now we have 8, that we just took that one basket, created 8 baskets with 2 apples each. That's all we've done, 2 usable apples each. Okay, let's take a look. We had our original network 10.6.0.0/16. We decided to subnet it into 8 subnets using 30 usable hosts per subnet. We assigned our 4 buildings the first 4/27 subnets. We had 4 remaining. Okay, but we didn't want to use those 3 out of those 4 for our point-to-point links. So we took the last one, the /27, and we subnetted it into 8 subnets, each with 2 usable hosts. Okay. And we took 3 of those /30, so we have 5 of those left over, right? And we assigned those to those point-to-point links. So we have 3/27 subnets remaining instead of just 1. And we even have 5/30 subnets remaining. Okay. So all VLSM is taking a subnet and subnetting it further. Okay. Subnetting is taking a network or a subnet, they're same terms, subnetting it, and then taking one of those subnets and subnetting it further. That's what we did. We took our network, subnetted it into 8 subnets, 30 subnets each, 30 usable hosts each, excuse me. And we took the last subnet here, could have been any of these 4, but we subnetted it into 8/30 subnets. That's all VLSM is. Okay, so looking at our pie here, okay, we had those first 4/27s for our buildings. We took one of the slices, one of the 30 usable host subnets, and we divided it into 8 smaller subnets, and we used 3 of those. Okay. All right, router configurations. So this, looking at router R1, this interface here would have a /27 subnet mask, first host on that subnet. This interface here will have a different subnet mask. It's on a different subnet with a different subnet, one of the /30s, and we'll have the first address on that subnet. Okay. This build, and then our router R2, we can see that it has its LAN interface has a /27, but its point-to-point interface has a /30. It actually has the second address, or there's only 2. Remember, the /30s only has 2 addresses, 225 and 226 for this one, but just the 01 and the 10 bits. Okay. Okay, and we can keep on going and looking at these. Notice that the variable length subnet mask, different subnet masks of variable lengths, the VLSM. Okay, so just a reminder here that this is much easier in IPv6. Okay, so again, another reason we need to move to IPv6. We don't want this exercise in fertility of trying to conserve bits. Is, you know, it takes away from what we really need to be doing. That's focusing on IP traffic flow, security, doing traffic analysis, and looking at performance of our networks, and many other things we need to be doing. We don't need to be trying to conserve IP addresses. Okay, and let me show you how easy this would be in IPv6. we are given a /48, we can just give everything a /46. Let me go back here and show you. We're given a /48 by our provider. We can just subnet. We have a 16-bit subnet ID. We're just going to allocate a hexadecimal value from here, just increment it. So here we have our 0, 1, 2, 3 for our buildings, /64. But how many hosts is that? 18 quintillion hosts we can have per /64. Okay, not going to run out. How about our point-to-point links? Just give them a /64. Okay, we don't have to worry about conserving addresses. But there's only 2 addresses needed, usable addresses per link, Rick, and we're using 18 quintillion, a subnet that can have 18 quintillion. Isn't that wasteful? We're not cutting down binary trees or anything like that. It's okay. Okay. It's about making our life easier to manage our networks and do our addressing schema, our networking address plan, make it much easier. Okay. We don't have to worry about conserving these bits. Okay. We have plenty of bits to work with. Okay. That shows you that 64/64 gives us 18 quintillion devices per subnet. Makes our life much easier, and you're going to see that on the next video where I'm going to talk about subnetting IPv6. It's so easy.